let's take a look at your worksheet. That was page 129, 5K. What kind of questions did you come across that almost everybody did, all but 3? 14. All right, number 14. We have 10 plus 3i squared minus 4i. Okay, so the only thing that gets subbed in here is I plug a -1 in for the i squared. I plug a -1 in there, so that becomes 10 minus 3 minus 4i, which then becomes 7 minus 4i. Done.
Huh? What?
That's it.
Oh, because it's -1, right?
Right. Good. Go ahead.
So when you plug in the -1, it's basically like canceling the I.
Right. So I'm just going to plug. This is going to become positive 3 times -1. And then that's how that generates that. Good.
Wait, if I is -1, then why wouldn't it be?
I squared is -1, not I. I is equal to square root -1. And I'm not going to plug square root -1 in.
Okay.
Go ahead, Ori. Question? No. How much? 50? 50. All right, number 50. I got 10 over 3 minus 4i. All right. What?
That's not 50.
That's 51.
Oh.
8 over 2 minus I.
Yeah, that was semester.
589.
Is that it?
Yeah.
Sorry about that. Okay. Shh. Some of you are chatting too much. Let's, I don't want to have an I in the denominator, and I don't want a radical in the denominator. So the only thing that would make sense to me so far is to put that in parentheses. We good there?
Yeah.
And then I'm going to do the conjugate, because I know conjugate's going to get rid of the middle term. So I'm going to go 2 plus I root 3 and 2 plus I root 3. Is that okay? If I multiply on top, I'm going to get 16 plus 8i root 3. Just distribute. And then if I double distribute or FOIL, 2 times 2 is 4. Outside terms and inside terms cancel each other out. Agree?
Yeah.
And then the last term is going to be -i times I, which is -i squared. 3 times 3 is 9. So I get that. The problem's not done, but do you follow the work I did?
Yeah. So
I will eventually.
4 minus -1 times.
Yeah, when I multiply this and I multiply this together, they cancel out. They're opposite signed, exact opposite values. All right, so on top, I'm just going to keep this for now. On bottom, this is going to be what right there?
+1.
So that'll become a +1. Why is it a +1?
Because there's a negative.
And then that's times 3. So that becomes 4 plus 3, which is
7.
done. Agree? What else? Yeah.
30, 40?
40? So I get I squared equals negative this, negative 100. I'm going to take the square root of both sides. If I take the square root of both sides, we learned from Algebra 1 we have to have a positive and negative component. Okay? This technically breaks into, agree? That means this is I, agree? And that's 10.
We have to have a minus with the i's.
Well, when you take the square root of both sides, you create 2 roots. So I would say yes, I would like to have a plus or minus. I would say that's the 3-point problem. You forget the plus or minus, you're missing one of the points.
Doesn't I see, isn't that negative?
No.
So I is equal to the square root of -1, which that means I just put I in for that, and then I took the square root of 10.
No, I know that, but no, never mind.
So what you're eventually going to get to, we haven't even talked about yet. If you have one complex number, like 3 plus 2i, that means the conjugate of it will also exist every time.
Wait,
So
what?
3 plus or minus 2i will always come in pairs. So we're not there yet. That's like a week from now, or 2 weeks from now, because we have a break next week. Any other questions you want to see?
Did you do 17?
Yeah. $17. 4 minus 2i, 3 plus 2i minus I squared. Is that the one?
Yeah.
Okay. I am going to eventually distribute the negative 2i over the parentheses. But I think I could probably change this whole part right there to what?
1 plus 1.
If that becomes a plus 1. So then I get 4 minus 2i. Because that's a positive 1. Is that okay so far? You see what the math I did?
Yeah.
Wait. Okay. So what am I distributing over the parentheses? Just the negative 2i. These are conjugates of each other, but this was not grouped originally. So I'm just going to take the negative 2i there and there. Is that okay so far? We're good? So what does this become now? Is that a positive 4?
Yes.
So then I get 8 minus 8i. What else?
13.
You didn't do it, so you can't call it out.
Number 10.
Number 10. You didn't even have it out in front of him, so.
What?
You don't even have it out in front of you, so. Call him bunk on you. Number 10, you said?
13.
I to the negative 11. That one? Okay. First thing I'm going to recognize, if I have a negative exponent, that means it wants to move locations, meaning it wants to move from a numerator to a denominator or denominator to a numerator. Now, some of you are going, but it's not even a fraction. Now it is. So this is going to become 1 over I to the 11th. Is that okay? So I don't like a negative exponent.
Oh, okay.
Okay, so then realize this repeats, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th is what's happening. So think about how many times does 4 go into 11? It goes twice, and then I have a remainder of 3. You agree with that?
Yeah.
Like, so 4 times 2, that's 8 minus 3. I have a remainder of 3, like old school division. So I to the third power is equal to negative I. So then that's going to change into 1 over negative I.
Come on.
I don't want an I in the denominator, so I'm going to multiply both top and bottom by I and I. So I get 1I on top over I times I is I squared. I squared equals negative 1. So negative negative 1, I get positive 1, right? So my answer just comes out to be I. Because 1I over 1 is the same thing as I over 1, or the same thing as I. Huh. Yeah.
What about 8 is I to 0?
I to the 0? What do you think?
0.
What is, if I make I a variable and I get x raised to the 0, what is x to the 0?
0.
No.
What?
1.
Number. Oh, wait. Oh.
So I to the 0 has got to be 1.
Because isn't anything to the 0 to the 1?
Anything to the 0 other than 0. 0 to the 0 is
Well, that's
undefined. But anything else to the 0 power is 1. Or it could be negative 1. So if you have like negative 6 to the 0, if the negative 6 is improved, it'd be 6 to the 0, which is 1.
What do you 47?
47, yeah. Is that 12 over I squared?
Yeah.
What's I squared equal to?
Negative 1.
Negative 1?
Oh. Oh, can we do 48?
48? 48. is that 7 over I to the third? All right, let's get rid of the i's in the bottom. So I'm gonna multiply top and bottom by I and I. So I get 7i on top, and then I to the fourth is equal to positive 1. So that just gives me 7i. We good? Guess who moved the camera as they needed to squeeze by?
That was not me. That was definitely Grant. I just watched him do it. You were so mean to me. Just targeting.
Targeting.
Uh-huh.
All right. Make sure your name's on those and anything else you're handing forward. Please.
Really?
Anybody else back there?
Look at all these people from next row that did it. Stir, clearly nobody did it. Nobody did a thing. We did nothing. It was so stressful yesterday.
I was arguing with you. No one did it before.
Like, he's not wrong.
Story time.
Story.
Jolly.
And you know, Cooper, if you had done the homework, I had the greatest story I was going to tell today.
Tomorrow
on.
you're telling us
Cooper!
Is that Michael Bublé?
Yeah,
let's just not do any math,
Josh.
Or the orange.
Christmas.
Who?
Cooper,
Never
nobody
mind.
cares. Sit down.
Just the best Christmas singer in the world.
Oh, okay.
Aren't you telling us the orange story tomorrow?
Oh, no, the orange story comes right before
Halloween.
spring break.
Oh, I thought it was fall break.
No, fall break could be the Halloween story.
Yeah.
Can you tell us a story today, please?
No. You might have to show up tomorrow.
It'll make
You
me
should
so
tell us the
happy.
Halloween story on Halloween.
Okay, I
I'll be
will.
that kid.
So no story tomorrow then. Yeah.
Yeah.
No, story now. Can I tell a story?
Yeah. I should just create a class called Stir Up Story Time. Some elective class that you build your imagination in.
If you get credit for it, I bet people do it.
I think you didn't get
Like, you just get like a random credit. Oh, thank you.
So we get a humanities credit or something.
Or just like a miscellaneous credit.
credit for that one. Like the,
Like in,
what was the
like
kid's
Santa
name again?
Claus, it's just a miscellaneous credit.
Did
That'd be cool.
No.
that'd be chill.
What was your one story?
Eddie, yeah.
Eddie. I'm gonna sound like Tyler. Like
Eddie's
Tyler's story.
On Halloween, I will.
The exact same.
Like, you can do it tomorrow, I feel like.
Tomorrow's Friday. It's like,
What?
it's the day before.
Because Halloween is on like a Wednesday, so it's like not as like,
Not as spooky.
Let me tell you,
yeah.
it's this time of
So do
year.
it,
That could
yeah,
be.
do it tomorrow.
All right.
Michael Bublé, baby. I just said, you really don't know Michael Bublé?
I recognize his name. I just didn't recognize.
Are you a Christmas fan?
Christmas.
Yeah.
Well,
You should know Michael Bublé then. You were Santa. Obviously, you should know Michael Bublé.
Yeah, no, Santa was Santa.
Yeah.
You're mistaken.
Like, you have the same
I was in
identical
my
glasses.
office grading papers.
You have the same identical glasses and voice. I agree. Same height and everything too.
I had about
I talked
30,
to
40
Santa, it
pounds.
definitely wasn't him. Definitely not.
I love how we have this obstacle course. Like, I don't want to go in front of cameras.
Walking through a life. Where does it go after the book?
Listen to some Christmas music.
Alright. No.
Lighten the mood.
Alright.
It's okay, I'll just listen.
We're. Alright. So the concept of I think a lot of the gaps that you might have had from Tuesday start filling in real quick when you're like, oh, is that all it is? You know, it's a real. Want to go sing to the choir people? Just stand in the icy hallway and sing? Jeez. All right. So, am I correct thinking that as we went over the homework, a lot of the I stuff just kind of went, oh, That's all it is. It's not a. It's a unbelievable idea of imaginary numbers or complex numbers. But when you start looking and realizing that I can pretend I is just like any variable or any letter, but then I actually does represent 4 different things. It's not hard. So this first one, I just run through a few of these. You stop me if I get to something that I do wrong, which is very possible. Let's see.
It's 26i plus 3. What?
28.
Did I do it right? What did I do wrong? Because we're just adding or subtracting, right?
Oh, wait,
So
what?
2 plus 3, negative 4 plus
Oh,
7.
you're not multiplying?
No, there's an addition sign. That usually sticks out pretty good. Where'd that come from?
That's tough.
Sorry. I don't know how to fix that. Sorry. What are you doing?
It's not me. You always blame it on me.
I didn't want to be in the video, and I think I'm in the video now.
All right. Can I move on?
Uh-huh.
All right.
Yes.
Just going through. That's why it says we're just review.
Okay.
See up there, left corner says review. It's on your notes as well. All right. Does everyone agree that that part is going to become 2i root 5? Is anyone stuck on how I got that right here?
No.
Because 20 breaks down to 4 times 5. 4 is the largest perfect square that goes into 20. Square root of 4 is 2. All right, so now I can add it. Negative 9 and 3, negative 6. Plus I to the 5th and 2i to the 5th. I add those together, so I'm going to get 3i to the 5th. So notice when I'm adding them, they don't change at all. Good with that? Can I move on?
Yeah.
Okay. All right, now we're multiplying because we have multiplication. So 12i squared is negative 1, so I get negative 12. Agree?
Yeah.
64i squared is negative 64 because I get I squared, which is negative 1. This becomes negative 9. You're getting up again? Then you're going to have to get up to throw away the tissue. Then see what's in the trash. See if someone throws something in the trash. Easy.
Always on my head.
All right, ready? This is grouped. Agree? So I get 16i squared. 16i squared is negative 16. This one's not grouped, so I get 7i squared is negative 1, so I get positive 7. And this one becomes I to the third, which is negative I. So I to the third equals negative I. So I get 6 times 6 times 6, which is 216. And I get a negative I in there, so I bring in the negative out front. And let's pause. Do those problems make sense?
Yeah.
Is anyone stuck on any one of those? You need more.
Why is 9? Oh, never mind.
Why is 8 negative 16? Not positive.
Okay, so you're absolutely right. Negative 4 times negative 4 is positive 16, but then I have I squared, and I squared is negative 1, so then it becomes... So this would have become just 16, and then I get I squared, and then the I squared is negative 1.
Wouldn't it? Okay.
So this means the same thing as this. Negative 4i times negative 4i. Squeeze in there. So negative times negative is positive. I times I is I squared. And because I have an I squared, that's negative 1.
Okay.
We good? May I move on?
Yes, sir.
All right. So I recognize that I'm going to have an I for part of my answer. I'm going to have a 2 for part of my answer, and then I have a root 3. Where did that all come from? Well, the I came from there. And then that's 4 times 3, bless you. It's still under square root, so square root of that. Agree?
Yeah.
Do what?
What's the answer?
Here's the answer right here. 2i root 3.
What?
Okay, I do have a negative down here, but I don't want to mess with it yet. So I'm going to multiply both top and bottom by root 2 and root 2. So that's actually giving me on top 2 root 2. On bottom, I get negative 36. Is that okay?
Yeah, but
What's the square root of 36?
6.
What's the square root of negative 36? 6i. I don't want an I in the denominator. Multiply top and bottom by I and I. So then on top, I'm going to get negative 2 root 2i. And then 6i is 6i squared, which is negative 6. Negative over negative is positive. And I can reduce here and here. So the answer becomes root 2, I root 2 over 3.
I didn't move that.
Oh, yeah, you're right.
Here, I'll change color. Maybe that made.
do square root 2?
Because it used to be negative 2, but then it's 2.
I wanted to make a perfect square on bottom.
1/3.
So then it's 1/3.
Okay, so I can reduce everything outside. That's where that happened. And then I move the I out front. And then the negative over negative is positive. All right?
Yep.
Can I move on? Okay, we good? All right, I don't want to have a radical in the denominator, so what would I have to multiply times 10 to make it a perfect square? 10 sounds good to me. So I'm going to multiply by root 10, root 10. Okay, so on bottom, my answer is just going to be 10 because root 10 times root 10 is root 100. Root 100 is 10. On top, I'm going to get,
10 I root 2.
I get that. So there's an I that's going to happen. So I get, as you said, 10I root 2. And then can I reduce that 10 and that 10?
Yes.
So what's my answer?
I root 2.
I root 2.
Oh, wow. That's crazy.
Oh, that's too easy.
FOIL, 2 times negative 2, negative 4. Outside, I get negative 8i. Inside, I get negative 2i. Minus 4i squared. Okay, you're going to have some like terms. What is this right here going to turn into?
4.
Positive 4. So positive 4 and negative 4 is 0. So I'm going to get negative 10i. I guess I could put 0 minus 10i if you wanted to.
What does the I mean?
Square root of negative 1. So you're dealing with, now we are out of the no real solution to we have a solution which is a complex solution. A complex meaning it's an imaginary number. There are other complex numbers that aren't imaginary. But
What do imaginary numbers really do?
the inside math of everything else. Like that, just that. The math that takes place in between the math. So in between dimensions, when you multiply things together, you change the dimension of it. So from 0 dimension, which is a point, 1 dimension, which is a line, to 2 dimensions, which is like a square or circle, 3 dimensions, 4 dimensions, 5 dimensions, keeps going. There's an infinite amount of dimensions. We can only fathom really 3 of them. Sometimes we can say, well, times the dimension, but it's only half the dimension because we only know how to go forward into it.
Cool.
Yeah, it kind of gets weird. But then you're talking about like the 2.5 dimension. Where does that exist? In the imaginary world. Of course it's imaginary. You're just making stuff up. No, it's real. All right. 36 minus 9i minus 8i minus 2i squared. Oh, don't even get to the matrices. That's great stuff. All right. What is this?
It's supposed to be
2.
plus 2i.
Plus 2i, so I get 38 minus 17i.
Yep.
All right, that's a 7.
17? Yeah.
Wait, no.
Yes.
No?
Because when you multiply that negative 2i times negative I, it's supposed to be positive.
Positive.
So it would be negative.
What?
No.
Because no, it's negative 2i squared, so I squared is just a negative 1. So it's negative
No,
1
I
times
know,
2,
I know, but-
so that's 2.
No,
Okay,
Plus
but when you
36.
but below like negative 2i times negative I is a positive 2i squared, so it should be negative.
Oh.
Should be 34.
You are right.
What are you? I'm so confused.
Because I went a negative times a negative. That should have been a positive originally. Olivia was quick on the draw. Good job.
Thank you.
Don't applaud, just throw money. All right, when we do this one, the middle terms fall out because they're conjugate. So I get 25 minus 9i squared, which that negative 9i squared is positive 9. So that's going to be 34. Agree? Does anyone need to see me multiply out negative 15i and positive 15i?
No.
Okay, good. I have 2 of these, so I'd write it out. So that's going to give me 9 minus 12i. Minus 12i is minus 24i. Plus 16i squared. I squared is negative 1, so that's negative 16. So that's going to give me negative 7 minus 24i. Conjugates of each other, so I get 121 minus 36i squared, which is 121 plus 36. That should be squared, sorry. 157. Yeah. What are we doing on those?
We have like a lot more.
Do we have homework over break?
No.
Are we like not
Do all the math. All right. Root x equals plus or minus 8. Yay?
Yep.
Divide by 5. Divide by 5. What is that? 16. So x equals plus or minus 4. X squared. What is that? 98. X equals plus or minus root 98. 98 breaks down to 49 times 2. So that becomes x equals plus or minus 7 root 2 because it's square root of 49.
So, okay. Yep. So it's always plus or minus. There's never like an I there.
On these, no. We just
Okay.
refer back to algebra 1. All right, sometimes you take the root of the whole side. And then you add 4. So this is just algebra 1. So that would result in 2 answers. You have 10 and negative 2 for answers.
Yep.
This one, it looks like it's going to be negative until I divide each side by negative 5. So I get positive 1. Root equals square root of 1 is 1. So I'm going to subtract 8. There's 2 answers. Negative 8 plus 1 is negative 7. Negative 8 minus 1 is negative 9. Good. All right. See if you can figure out what I did. What did I do right here? You weren't done? Here you go.
Where root?
Oh. If both sides of the equation are perfect squares, do not expand the binomial. Remember your 2 roots. Okay, we did that. You done? Cool. So I took the square root of both sides. Let's see, add 4. Divide by 3. So 4 plus, so that's going to give me 15 over 3, which equals 5. 15 minus 11 is negative 7 over 3.
15 minus 11? What?
4 plus 11 is 15.
Yeah.
Divided by 3.
4 minus 11 is
He
negative.
was right.
Negative 7.
Yeah, no.
Oh, wait. So there's my answers, 5 and negative 7/3.
Yep.
What did I do?
know, we really are.
What did we do?
We know we are.
Any more of these need to be worked out?
Oh,
22.
22, you got it. 22. What's the magic I would do on 22? Skip it's not the magic. Clear the denominator.
No, she does not.
Multiply everything by the denominator. Is that okay? Could you go ahead and work it out from there? Add 5 so you get 20, divide by 2 so you get 10. So then this works down to c minus 2 squared equals 10. root, c minus 2 equals plus or minus 10. So I get 2 plus or minus root 10, which is a nice irrational number. Rational means you can make it a fraction. Square root of 10 is an irrational number. Am I done?
No.
Any of these you need me to do?
No.
So these all have I as part of it. Right?
But wouldn't it not be minus?
Negative.
It wouldn't be plus or minus. 5i would just
Because
be
I took the square root. If I take
adding
the square
5i.
if I take the square root, I have to have positive and negative components.
What if
What?
it's x?
Yeah, but it can't be like plus or
Ooh.
negative.
Why is it I?
Let's worry
It's
about
just
that
5i.
Huh?
It's just 5i, not plus or minus 5i.
Plus or
Because
minus.
if you do minus, then that turns
I'm
different.
confused.
This plus or minus took place because I took the square root of each side. So it comes along automatically
Wait,
to the right.
so why didn't you do I with the other one? What?
The other ones didn't have any imaginary numbers. But this one, because I had a negative square root, I had a...
Okay.
Yeah.
We have x cubed on the whole.
Oh, okay. X cubed?
Yeah, one of them has an X.
Oh, divide both sides by x. So 17, you can do one of two things. 8x to the third plus 2x equals 0. Factor out a 2x and go from there. Is there any of these others you need me to work out?
My mom.
I didn't hear anybody. Is there anything else down here that I should look at? We good? Last one, I think. Okay, these are going to be done the same way. Any of those need me to do? And then this one. All right. Graph each function, identify the x-intercept as exact value. So this has a vertex of 4, negative 3. What are you guys packing up for?
Why not?
Okay, you're moving around too much.
Flipping on page.
Oh, okay. Love you guys. Sorry. All right, how's it growing? Is it growing right one up one, left one up one, right one up 3? Is that right? Correct? All right, so right one up one, left one up one. Agreed so far? Right one up 3, left one up 3. Okay? What don't you understand? This last
It's
one.
not. It's the
I
same
just
thing.
don't know how to like graph this.
Okay.
That's the same thing as last unit.
Yeah, I know.
How
I
is it
never
different?
found out how. Like I never.
Well,
it
do you-
doesn't make sense
okay.
to me.
Do you agree that that's in vertex form?
Yeah.
Are you okay with how I got the vertex?
Well,
So-
because it's just the
Opposite one
Y
group,
and
same
the-
outside.
okay.
Okay? And then the pattern graph, because I have a outside the x is a 1. You don't see it, but it's there. So then you pattern graph as right one up one, left one up one. From that new point, go right one up 3, then right one up 5, then right one up 7. Keeps going forever.
Okay.
Okay? So, does anybody know these? I see that it's crossing there and there, but I don't know the exact value. Your calculator could zoom it a little bit. Okay, but let's try and graph this one. I have a vertex of negative 3, positive 4. So I have negative 3 and then positive 4. Agree with that?
Yeah.
Now this one's not going to go right one up one. It's going to go right one up 2. Olivia, with me? And then from there, it wouldn't go right 3 or up 3. It's going to go up 6. So right one up 1, 2, 3, 4, 5, 6, which is kind of off our screen, but still. Okay, so here's the difference between those. Does this red cross the x-axis?
No.
So this means that the roots, which another word is solutions, which is another word for zeros, are complex. That's a C with a slash through it. That means they're imaginary. It means that if I multiply that whole thing out I use the quadratic formula, I would wind up with a square root as b squared minus 4ac. When you plug it in, that square root would be negative. Okay? This one, if we found those roots, we might find those to be rational or irrational. Rational means that I could find exactly where it crosses the x-axis. I would know, even if it's a decimal, I'd be able to find the fraction that goes with it. Irrational would mean it's some decimal amount that we'd never be able to reach to. So we might have wound up with like plus or minus square root 5. Plus or minus square root 5 is an irrational number. Is that it? Okay, so that means L is our homework?
Yep.
All right. And we have time. Do you want any
Story.
What do you want?
Anything.
You want an inspirational one?
Yeah.
Please, sir.
All
right. I gotta look something up real quick. See if I can find it.
What?
All right. So while I'm looking something up, I will start this little story. You still with me? So I feel this is pretty inspirational. It is sad, but it's inspirational.
The same way that the Eddie story is inspirational.
So you know me. I always say to you, take care of one another.
Yeah.
Yeah. What happened, Mr. Stirrup?
So a friend of mine in Arizona, he was a captain for the Gilbert Fire Department,
Oh.
which Gilbert, Arizona is part of, it's one of the suburbs of Phoenix. So he passed away this summer. He had a brain aneurysm, brain bleed. It basically made him stroke out and die. His daughter is your age. So the fire department on the first day of school took her to school.
Oh.
That's awesome.
But look at how many,
Is it in high school?
yeah, she was at Gilbert High School. And there she's walking up to campus. Look at that. That's the whole community. It's all the fire department. They had like 20 different service or different fire departments that showed up for this.
Yeah.
And when I say 20 different, like Gilbert Fire Department, Chandler Fire Department, Temme Fire Department.
That's some love.
So that right there, guys and girls, is what it means to take care of one another. So on that note, get out of here. Have a great day.